Okay, so today we're going to again continue the lesson, and it is about probability. And I've said before, guys, please write this down because there's a couple of things that you might want to write it down for notes. And previously, we have learned about singular probability, right? Where we only have like one event. For example, you throwing a die one time, or you throw a coin one time, or you take a marble, just one marble from a bag, for example. Now we're going to talk about how if we have like more than one event. I mean, like we take like it's you don't just like throw one die, maybe two dice, or maybe you have two coins or three coins, or maybe you have like more than when you take a marble, so, you take it more than once. And how are we going to calculate the probability of that kind of event? Okay, so I'm gonna again explain what I've just explained in my YouTube channel. And from the first one is the tree diagram. Okay, so when we're talking about probability, it can be actually presented in many ways. For example, you can do it in tree diagram, you can make a table, or you can even make it as a graph, for example. But today we're just going to focus on tree diagram and also table. Yeah. Okay, so this is for the first example. Again, you can see it in the YouTube videos that I've just made last week, last what they call last Wednesday. And here we go. So this is the first example. So if you have two coins, you toss it once. Yeah, you have two coins here. You toss one. You toss it once. What is the probability that you're getting both head and then blah blah blah? Yeah. So the first thing that you need to do here is that you need to know what are all the possible outcomes. Okay. So before I make the trade diagram. Okay. So the first thing that you need to understand that you need to know how many outcomes do we have? How many options do we have in here? Right. So the outcomes that might happen is that for the first you'll get like head, and then you'll get head tail, and you get tail head, and then you get tail, right? So these are the only possibilities that you have from tossing two coins, right? The event that will happen are only these four. So basically, if you don't want to make a tear diagram, you can use this, right? Okay, so for example, if you want to know if you have getting both heads, so which one is getting both heads? So this one over here, right? So it's just head and head. So because we only have one, so for that example, so that's PA, the probability of event A, that will be just 1/4 because we only have one head, right? Both head. And then we have four possible outcomes. So remember that we actually have one formula for that. So probability of event X will be equals to NX over NS. So what the NS is the all of the outcomes. Okay. So for question B, getting one head and one tail, we had one head and one tail is, I'm gonna erase that blue first. Wait. Ya, error. Bentar guys. Dia suka error ya, sabar ya. Wait, cotomate kudasai. Sorry ya guys, saya agak sedikit buru-buru mau ke dokter lagi kayaknya nih saya. Aduh. Obatnya udah habis. Okay. Okay, here we go. So B, getting one head and one tail, right? So which means that we only see the outcomes in which we have one head and one tail. So the outcomes that we have is these two, right? One head and one tail. Why is it not this one? Because this is two head. It doesn't have any tail. This one only tails, two tails, but no head, right? So which means that we have those two. So the probability of getting the second event will be 2/4. Again, this 4 comes from all of the outcomes, right? Because we have 4 options here. So 2/4 can be simplified as 1/2. Okay, and the last one here, we have getting at least one tail. So at least one tail means that you can have one tail or more than one tail, right? So you can, so in this case, you will get these three, right? So again, why we cannot have this one? Because that one doesn't have any tail, right? Okay, so probability of the event C will be equal to 3/4. Again, the 3 comes from this 3 and the 4 comes from all of the outcomes. Yeah. So basically, again, you don't really need to draw a tree diagram if you don't want to. If you can just like list it like this, it's fine, no problem. Yeah. Okay, let's go to the next example. Okay, here we go. The next example is what do you call it? The marbles, right? So in here we have two different color marbles inside a container. Okay, so but this time you take it twice. Okay, you take it twice. So be very careful when you see this kind of question. The keyword in here is this guy over here. This guy. Okay, it will be different if the case is with replacement. Okay, so let's read the question again. So we have 6 red and 9 blue marbles in a container, and you take it twice. You take it once and you take it twice. But when you take it when you take one marble, you don't put it back again and then you take it again, and then you take one again. No, but you take one, you keep it, and then you take it again from the container. Okay, so because we have this keyword over here, right? That without replacement. Okay, the question is, what is the probability of getting both red? Okay, so again, guys, so you can have red, you can have blue, but in here you can't make it like this because we have like 6 red and 9 blue. If you make it like this, it will be like a lot of tables or a lot of outcomes, right? Instead, we're going to use the tree diagram for this one. Yeah. So the tree diagram will be like this because we take it twice. So you make it like the first time you take it and the second you take it, right? The first time you take it, you get like the red and then the blue, right? So red and the blue. So I'm gonna, okay, so the first one is the red and the second one is the blue. Wait, let me multiply that a little bit. Okay, oh, kecilan ya. Here we go. Okay, right? So the red one will be, here we go, guys. Again, the first thing that you need to see that how many outcomes do we get? Okay, how many NS is it, right? How many marbles inside? Because we have like 6 and 9, which is equals to 6 red and 9 blue, which means that we have 15 marbles, right? So we have 6 plus 9 equals to 15. So that will be the NS. So when we have this, it will be like over 15 for both of them, right? So that will be the denominator. So the one that you need to see again here, guys, is the number of red that you have. For this here, you have 6 red. So for if you have the red, you will get the probability of 6 over 15 because you have 6 red out of 15, right? And as for the blue one, that will be 9 over 15 because we have 9 blue marble from 15 marbles, right? So that's the first one. For again, the second one, be very careful. If you don't have this word over here, this phrase, yeah, that phrase, and it said that you replace it again, the denominator will still be 15. Will still be 15. But this time, because you didn't put it back, so you will reduce the marble by 1. So it depends on the case in here. So if we take, okay, so let's assume that we have the first marble as a red. Right. So the second time you take it, it can be red. It can be also blue, right? Right. So now what is the probability that we will get a red? But because we assume that we have a red on the first time we take the marbles, right? So which means that the red in here is not 6 anymore. It's 5 because we have taken 1 marbles, right? And the same thing with the marbles that we have in here, which is 15. And since we have taken 1 of that, 15, so it will be reduced by 14. Okay, does that make any sense? Right? Yeah, yeah. The same thing here, guys. Again, you focus on this branch, right? First, okay. So as for the blue one, it's still over 14, right? Because we know that we have taken 1 marbles, but in here we still have. So I'm gonna put it here, guys. Sorry, it should be blue. Right? But in this case, in this branch, right, the blue hasn't been taken yet. So it's still 9, right? You still have 9 blue marbles inside the container, but out of you get 9 out of 14 because you have already taken 1 of the weight. Yeah, because you have already taken one of that. Okay, so that's the first branch. The second branch in here, the same thing. If we assume that we get the blue one for this one, right? We get the blue one, well, the first time we take it. So the second event, we can have blue and we can have red. We can also have blue, right? The same thing. But for this time, again, the red marbles hasn't been taken yet. If we use this branch, right? So we assume that the first time we take is blue, means that the second one, right? The red hasn't been taken yet. So it's still 6, right? So this is 6 over 14. And as for the blue one, means that this is going to be 8 over 14. Again, where do we get the 8? Because we assume that we have taken one blue marbles, right? One blue marbles. And again, the 14 comes from because we have taken 1 from 15, we get 14. Okay, so in here, guys, whenever you see this, what does this every branch means? It means that for the first branch, we will get red and red, right? Red and red for this branch over here, right? So how can we calculate the probability? You only need to multiply. Again, if you have like two more, like twice, 3 times, 4 times, you will multiply. Because why? You cannot add them, because if you add them, it will be like more than 1. If you have more than 1, that it's not a probability, right? Because we also have learned that probability takes places, the value of probability is not between, from 0 to 1. Okay, so the red, the probability of getting a red, it will be 6 over 15 multiplied by 5 over 14, right? And for this one, that will be red and blue, right? And that will be 6 over 15 multiplied by 9 over 14. And for this one, that will be blue, red. And again, that will be 9 over 15 multiplied by 6 over 14. You only need to like see the branch, guys. Yeah. So it doesn't really, I mean, like it's not that hard. You only need to follow the branch. You have 9 over 15 and then multiply by 8 over 14. So basically I have made this table here in the graph. Oh, wait, I'm going to go here, guys. Here we go. And I'm going to copy paste this one. Wait, I'm going to put it here. So that will be, I'm going to write it down, guys, 320 over 210. This one is 54 over 210. And then you get 9, and no, 54 again. 54 over 210. And last one will be 30 over 210. Okay, so this is, again, what you need to see, guys. Whenever you have these values here, all of the probabilities, if you add them, that will be equals to 1. If that is not 1, then you might mistaken for the calculation. It should be 1. Can you see that? 300, ikot ya, sorry guys, ada yang salah. Itu harusnya 30 ya, maaf. Yang paling atas 30, mohon maaf, salah tulis. Ya, oke. Okay. Ya, oke, silakan. Yeah, guys. So whenever you see, again, guys, if you have this branch again, if you make a tree diagram and then you have all of these branches, if you add them, it will be always equals to 1. Again, if you don't have equals to 1, then you might have mistaken for calculation for like these. Yeah, maybe one of them, maybe two of them, maybe all of them, I don't know, but there might be some miscalculation there. Okay. So let's go back again. If I go back to the coin again, if I go back to the coin, going back there, yeah. I'm going back to the point here. If I make that in coin, right? So the first coin and the second coin, right? The first coin will be head and tail, right? The head will be 1 over 2, tail will be 1 over 2. And then this is also head and tail. And this is head and tail, right? This is 1 over 2, this is 1 over 2, 1 over 2, 1 over 2, because we know that yeah, for one side out of 2, right? If you get head, you will get 1/2 times 1/2, you will get 1 over 4. The same thing here, we get head tail, that will be 1 over 2 times 1 over 2, 1 over 4, and that will be tail head, that will be 1 over 2 times 1 over 2 equals to 1 over 4. And the last one, tail will be 1/2 times 1/2 equals to 1/4. If you add them again, guys, 1/4 plus 1/4 plus 1/4 plus 1/4 is equals to 1. Okay, so please pay attention to that, because when I give you later, guys, I will give you a task for today. Only 3 questions. Yeah, 2 or 3 lah. Yeah. And when I ask you to draw this, I would like you to add them, and it needs to be equals to 1. You need to make sure that it is equals to 1 to make sure that your calculation is correct. Okay, so in here you can simplify it if you want, but you don't really need to for this one, unless you go back to the question, right? So if I go back to the question again here, the first question will be get both red. So that will be this one, right? Red, red, right? So I will take that. Oh, that is the probability of getting red, red. That will be 30 over 220, because I have made this table. If you don't, I have made this tree diagram. If you haven't made this, then at least you have to write down this one. Yeah, at least you have to write down that one. Okay, so 30 over 210 is 1/7. You can just simplify that. Yeah. Okay, the next one is getting 1 red and 1 blue. Okay, 1 red and 1 blue. Actually, we have 2 of that, right? So what go? Aduh, suka error deh. Bentar ya, guys. Suka error. Wait. Let me. Okay, here. Okay, getting 1 red and 1 blue. Getting 1 red and 1 blue, we have actually 2 of that. 2 possibilities, right? That are B or BR, both of them 1 red and 1 blue. So which means that we will have these 2, right? So what should we do with that? We add them, all right? We add them. So again, when we have this branch, right? We don't need to multiply anymore. We only need, if you have more than one, like, oh, maybe like the possibility is this one and this one. So you add these 2 numbers. Okay, so you add those 2 numbers. So again, if the question is this, getting 1 red and 1 blue, because we have these 2 branch, so you will get 54 over 210 plus 54 over 210. These 2, right? And then you add them together, that will be 108 over 210. Okay, and then you can simplify. Okay, last one. Getting at least 1 blue. Okay, at least 1 blue. We have this guy, and then we have this guy. Right? Again, the same thing. You add them. 54 over 210 plus 54 over 210 plus 30 over 210. Okay, so this is if we want to make a tree diagram. This is the example. Okay, again, you can see it in the what do you call it, the YouTube. I have explained all of them about this. You can see it again if you forgot. Okay, the last one is for the table. Yeah, for the table, we make it sometimes if we make a tree diagram. Sometimes we make it like plenty of branches, right? So instead of making a tree diagram, we can make a table. For example, this. Okay, so I'm gonna illustrate for you why I mean, like, it's not a good idea if you make this into a tree diagram, for example, right? So if I take, oh, this is the first die, and then this is the second die. Okay, so okay, 2 dice are being thrown once. What is the probability of getting 3, at least 4, blah blah blah, right? So if I know that the first die will have 6 side, right? So I will have six branch. 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5. Yeah, 6. Yeah. So that's the first one. So notice that if I get a 1 in my first throw of the dice, the second one I can still get 1 until 6 for the second die, right? So the second die will be like 1, 2, 3, 4, 5, 6. And it's 1, 2, 3, 4, 5, 6. Notice that there will be a lot of branches, right? So it's not a good idea to make a tree diagram if you have this case. So I'm going to erase that, right? Okay, so we're not going to use that. So instead of that, we're going to use a table. So table is more appropriate if we have this case, yeah? Again, it doesn't mean that one case to the other, like, yeah, I mean, like, different cases can have different methods to it, right? You can actually use both of them, but sometimes it's a good idea if you think first which one is more appropriate to be used. Yeah. Okay, for example, this one here. So we have, let's say the first die is a red die and the second die is white die, right? So actually we can have the same color, but let's assume that we have different so that we know that which one is the first one and which one is the second one. Hold on. Okay, sorry. Okay, so in here, guys, so the question is, what is the probability that getting a total of 3? Means that if you add these two numbers, the number that comes up from the first die with the second die, you sum it, you total it, you will get 3. That's the first question, right? That's the first question. You get a total of 3. So in here, we make a table, right? So 1, 2, 3, 4, 5, 6 for the first die, because that is the outcomes. And the second die will be also 1, 2, 3, 4, 5, 6, because both of them are the same die, for example. Yeah. And we can match them. For example, this guy over here, 1, 1. What does that mean? It means that the first die will come 1. Oh, I mean, we show 1. And the second die will also show 1. This one, the first die will show 1. The second die will show 2, for example. Yeah. Okay. Like that. You read it like that. Okay. So let's just go back to the focus here, to the question again. Getting a total of 3 means that you will get a 3. So for example, if I take this one here, that will be not 3 because 1 plus 1 equals to 2. That's not 3, right? So that is not going to be one of the answer for question A. So the question A will be this guy and also this guy, right? Because only those two, which pairs, if you add them, equals 3, right? 2 plus 1 is 3. 1 plus 2 is equals to 3. If you don't have any other pairs in here that if you total equals to 3. Okay. So which means that the probability of getting that event A, question A, that will be equals to 2, right? Because we only have 2 of these over the total outcome, which is equal to 36. Where do I get the 36? Basically, it's just like two-dimensional shape, because this is like this is not a rectangle, actually it's a square, because 6 times 6 is equals to 36, right? Right, 6 in here and 6 in here, or you can just count it if you want. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, sampai 36. Yeah. Okay. Okay, so there we go, guys. So this is question A. Yeah? Question A. Those two. Okay, let's get to question B. Okay, question B. Getting at least a total of 10. A total of 10. At least. Again, be careful. At least means that you can get 10 and more. 10, 11, 12, 13, 14, and so on, so on, so on, right? At least means that the minimum is 10, but you still can get 10, right? So probability of getting B. So let's mark them up in the table here. I'm going to use my blue here. Okay, total at least total of 10, right? So let's start from 10, okay? 10 can be like 5 plus 5, this guy, right? And it can also be 6 plus 4. It can also be 4 plus 6, right? And you don't have any other pairs of numbers which we add equals to 10, right? Only these 3. And because it said that at least a total of 10, so you can get more than 10. Okay, let's go to the next number, which is 11. 11 can be from 6 plus 5 or 5 plus 6. Okay, but 11 can be 1 plus 10, but yes, but you don't have a pair which is 1 and 10, right? So we only focus on the numbers, the pairs of numbers in which we have it in the table. Okay. And then the last one is this guy here, which is 6 and 6, because 6 plus 6 equals to 12. Okay. Okay. Although we know that at least 10, Pak, 13 kan bisa, tapi kan we don't have any 13 here, right? So it's excluding, yeah? So we only need to focus on the table here, right? So because we know that we have 1, 2, 3, 4, 5, 6, right? We have 6. This one is 6. 1, 2, 3, 4, 5, 6. Yeah, we have 6 total possibilities that we have here. So that will be equals to, right, 6 over 36. 6 out of 36, right? Simple as that. Okay. Okay, I forgot to simplify this. This is 1 over 18. This is 1 over 6. Yeah. Okay, last one is, you see, I'm gonna use green this time. Okay, a total of less than 5. Less than 5 means that 5 is not included. Yeah. Again, be very careful. A total of less than 5 means that 5 does not include. It can be like 4.9, 4.8, right? But again, because we don't have any decimal number here, so let's just assume we have like only integers or whole number, right? So a less of 5 means that less than 5, we start from the first number, which is 4. So we can just see, okay, the total number, if we add equals to 4, it will be this one, and this one, right? So those three, if we add those pairs of number, that will be equals to 4, right? And the next one will be this one, because that is also less than 5, which is 3. And also this one, if you added it equals to 2, and that will be less than 5, right? So we have this again, we have 6. Yeah, coincidentally, we have 6. Yeah, the same with the B, but yeah, you don't have to worry about that. Okay, so that will be P. Probability C, that will be 6 over 36. I'll simplify that, becomes 1 over 6. Okay, so this is the example of how to use T diagrams and also table. Again, guys, when we have probability, actually we have a lot of cases, but we're only talking about simple probability, because if you're talking more advanced probability, the numbers will be a lot more complex. Yeah, but this one, let's make it simple, and yeah, this is the example. Okay, any question before I continue to the next topic? Yeah, okay, no problem. Question, yeah, okay. Again, if you still want to see the topic again, you can just go to the YouTube. Yeah, okay. Now, I would like us to review a Venn diagram. Okay, so if we go back to grade 7, semester 2, the last semester, semester 2 at the, no, yeah, semester 2. We have set. Yeah, the topic of the topic of the lesson is set. If you go back to grade 7, and we have learned about Venn diagram. Okay, so we're going to use that to see some cases to calculate probability. Okay, so I'm gonna go to my slide here. I have one slide. There you go. This is actually the slide from the previous topic. I mean, like from grade 7. But yeah, let's just go back here. Okay. Okay. So again, guys, if we have sets, means that we have like, I mean, like if Venn diagram, we're talking about sets. In here, for example, we have sets of number. Set A is 4, 7, 9, and set B is 1, 2, 3, 4, 5. And then if we draw that in a Venn diagram, it will be like this, right? If you still remember that, yeah, if you forgot, just see it here. Okay, I'm gonna explain a little bit here, re-explain that a little bit. Yeah. Okay, so why is the Venn diagram like this? Because we have these two sets, set A and set B, and that will be, the Venn diagram will intersect between set A and set B. Why? Because we have the same element, which is 4, from both of the set, right? Which is 4. So that's why 4, we put it here in the middle, in the intersection. And the 7 and 9 only on the A side, which is this guy, and 1, 2, 3, 1, 2, 3, and 5 is on the B side. Okay, so that's the first one. If you hopefully you still remember, yeah. And then actually, guys, if we have more than that, okay, 0, 6, okay, because here, guys, it said that using the number 0 until 9, right? You haven't seen some numbers, right? Which are 0, 6, and 8. Right? So 0, 6, and 8, we put it outside. So this guy here actually is the universal set. So we tend to write it down as itu semesta ya. Oh, no. S for Indonesia, yeah. For English, we use U, yeah. U is for the universal set. Universal set means that everything that inside the rectangle, yeah. Everything inside the rectangles must include 0, 1, 2, 3 until 9, right? And then you have set A and set B, and then you put it here. And then you have made that into like circles, and then you make intersection. And whatever that haven't been included yet from the universal set, from here, we put it outside. Okay, so this is, I'm just gonna give you a glimpse of that. And yeah, okay, so I'm gonna give you one example on how one question of Venn diagram can be a probability question. Okay, so I'm going to go back to my one note. Okay, go back here. Okay, here you go. Okay, if you still remember, okay, udah masih ingat ya guys. Yeah. For example, in a class, there are, sorry ya, maaf ya, dulu saya tulisannya lupa. There are 40 students, yeah. Okay, let's say 25 like science, 20 like likes, yeah, likes for example social studies, yeah, social studies. Okay, and then yeah, and then the question is how many students like boats? Oke, ada yang bisa jawab ini? Saya kasih plus poin gede. Silakan. Silakan dicoba guys. Biasanya Egan atau Valdi nih. Both science and social studies. Masih ingat? Lupa? Hitung sampai 10 ya. 1, 2, 3, 4.
Oke.
Balik ya.
Oke, jadi begini nih. Jadi ditambahin jadi ada 40 students kan. Jadi itu yang suka science ditambah yang suka social studies.
Yes.
Habis itu dikurang yang suka dua-duanya.
Iya, jadinya.
Jadi itu formalnya.
And then?
Okay. Jadi ditambahin dulu yang suka science sama yang suka social studies, okay? So 45 kan.
Ya, oke, terus?
Habis itu jadi 45 minus yang suka dua-duanya.
Oke, jadinya?
Jadi ya we do a little switching. Habis itu 45 minus 40. Jadi yang suka dua-duanya is 5.
Oke. Terima kasih Valdi. Yes, 10 point for you. Yes. Okay, here we go. I'm going to explain, yeah. Why is it 5? Yeah. So basically we have that formula, yeah, that Valdi said before. That will be NA union B equals to NA plus NB minus NA intersection B, right? So in here we have this as the N union B, all of them. So that will be 40, right? And A is, let's say it's the science, you get 25. And NB, let's say it's the social studies, you get 20. And minus, let's say this is X, yeah? That will be, the intersection means that both of them, I mean like these students will like both science and social studies. That will be equals to 5, right? So it's not 5 yet, but let's assume that it's X, right? Don't know yet. So that will be 40 equals to 45 minus X. So X will be equals to 45 minus 40 and will be equals to 5. Okay, if you still remember. If you don't, ya udah lihat lagi catatannya. Okay, so how can we draw this in a Venn diagram? Okay, so since we know that we have 5 in the middle, right, as the intersection, so we can draw it like this. Okay, so in here we have 40 students, right? And since we know that there are students who like both of them, right, both science and social studies, then we can have, then we have the Venn diagram as an intersection Venn diagram, right? Something like this, right? And since we know that the students, the number of students who like both social studies and science is 5, so you put 5 in the middle, so like inside the intersection in here. Okay, so let's say this is the science, this is the social studies, right? And since we know that we have a science student is who likes the students who like science is 25, but we have taken 5 of that, so which means that this guy is 20. It's not 25 anymore because you have taken 5. 20 plus 5 equals to 25. And the same thing with this guy here, 20, right? So it should be 20 here, right? But it's not 20 because you have taken 5. So it's not 20, it should be 15. And you can make sure that if you add all of them, that will be 40, right? 20 plus 5 plus 15 equals to 40 because we have 40 students. Okay, so again, if kayaknya Diwa agak pusing ya. Gak pusing betul. Ya, nanti balik lagi ya guys. Okay, so question here guys. If I want this question into probability, for example, question 8. What is the probability, right? The probability that a student, a student likes, for example, science, right? And here, quite easy because we know that the student who likes science is 25. So that will be 25 over 40, right? Quite easy. Oh, that one is 25 over 40. Because we have 25 students, right? Like science, and there are 40 students. Quite easy. Okay. But what if I write it down? What if we have this question? What is the probability that a student likes only social studies? Yeah. Oke. Bentar ya guys, saya mau stop share dulu ya. Bentar, saya mau admit Adrian dulu ya. Oke. Halo, selamat pagi Adrian.
Bapak, aku habis dari check out hotel.
Udah dikasih tahu orang tua?
Belum ngomong sih ke bapak atau pak itunya, tapi aku baru aja check out hotel habis sama makan siang, makan malam, makan pagi.
Oh iya, nanti tolong dikabarin ya orang tua ya yang kabarin ke admin ya. Terima kasih.
Oke.
Oke, saya share screen lagi. Terbezo dikit ya guys. Allah Akbar. Oke. Kalau ini jadi gimana guys? What is the probability that a student likes only social studies? Hah? Riko mau coba Riko? Angkanya udah ada di situ loh. In the Venn diagram.
Okay, so the chance is 1 out of 40.
What? One? Where do you get the 1?
I can answer it perhaps.
Oh yeah, okay, I got it. Yeah.
15 over 40.
Okay, so why do you think it's 15?
Because the number of students that like both science and social studies is 5, and the total of students that like social studies is 20. You minus that 20 minus 5 equals to 15.
Okay, thank you very much again. Yes. Yeah, okay, 5 points. Okay, so there we go. So actually you can just like see it here, right? That 15 represent the student that likes only social studies in here. That's why we can use Venn diagram actually to illustrate what's really happening inside this class. So you will get this question later, yeah, in the exercise, guys. Okay, so you need to make the Venn diagram first to make sure to know which one is which. Okay, so if I add another question in which, yeah, it's probably almost the same with the previous question. What is the probability that a student likes only, right? Only science. You can see it from here, right? It's because that 20 represent the student that likes only science. So that will be PC equals to 20 over 40. Okay. So again, guys, the Venn diagram will be a lot. I mean, like it's going to be very helpful for you guys to illustrate a couple of questions because again, along the way, you will get more and more advanced calculation For example, when you are in elementary school, you might just see probability as, oh yeah, probability of a coin like 1/2, or getting a marbles or getting a dice. But this time we're going to more advanced. And for this one, we're going to use Venn diagram. Yeah. Okay, so actually this is it for today. I'm not going to give you a lot, but I'm gonna give you one question, not one question, one exercise, yeah, consisting like this. So one question consists like A, B, and C, but yeah, the same thing. I mean, like the answer will be like this, right? And only three question, yeah. Okay, before I give you the task, is there any questions? Jangan pergi dulu ya guys, saya belum absen. Any question, guys? And first, for those of you guys who haven't to go to YouTube, please go there because absennya masih saya kosongin yang kemarin tuh yang belum nulis. Jadi tolong ditulis dulu ya. Yang sudah kemarin, terima kasih banyak sudah kasih komen di situ. Saya sudah absen ya. Oke, any question guys? Ya, oke, tunggu ya. I'm gonna Bin, Adrian, Vira ada kan? Vira kemana? Aduh, Vira nggak ada mau. Oh, masih sakit ya? Oh my God. Oh iya, Vira sakit. Astagfirullahaladzim, saya lupa dia. Iya betul-betul. Wow, aku juga sakit ya. Dua, Edi, Egan, Paldi. Biasa. Ben, Kemal. Lina ke toilet tuh namanya ganti jadi Lina ke toilet. Zaidan, Reza, Iti. Ibu kemana? Ibu ada nggak? Ya udah guys, itu aja sebentar. Saya lupa.